If you've ever spent time wiring up a 3D printer completely from scratch, or just doing your own, like DIY electronics projects, you'll probably have spent time crimping terminals onto wires for connectors like these Molex XL and JST PH, I think these ones. Doesn't really matter. Either way, the process can be quite a little bit kind of fiddly because everything's so tiny and small. But one of the ways we can improve this and make it a little bit easier and quicker is by making sure that we strip the wire to just the right length every single time, and that actually doing that is not going to take absolutely ages. So today I'm going to show you how I modified my wire stripping tool in order to make this process very, very quick, simple, accurate and precise. So let's get started. So my tool that I use for wire stripping looks just like this. There are lots of others like it in different colours from different manufacturers, well, different name brands that have probably all just copied the same thing. And it's quite a little complex tool, but it works remarkably well. You kind of grip the handle and it grips on one side, cuts on the other, pulls them apart and you let go and it's all done. So on its own, already much better than many traditional basic wire stripping tools. The downside is it can be difficult to get the length just right. There's nothing, well, there is this big yellow stop that kind of comes with it, but for little connectors like I've been using on 3D printers, it's just not really suitable. It doesn't help, so I end up just taking it off and not using it. I then kind of line it up with parts of the screw to make sure things are the right length. It just takes ages to get that wire in just the right place. So what I've created is a little 3D printed part which we can attach to the tool to make sure that we get everything just the right length every single time. So this is the parts themselves. It's actually two pieces. This is the part here that permanently assembles to your tool, and that will just stay on there all the time. And then this part is the individual jig. They actually come in a set of various different lengths, so you have the different lengths needed for each of the different sort of crimp terminal types. So this is what the original tool looks like without any modification. Just so you know, if your tool looks like this, it should fit, because I'm pretty sure they all use the same geometry, but I've not obviously been able to buy them all to check. To assemble it, you can just very easily remove what's already there with a screw, like so, and this will expose this hole under here, which is an M3 thread, which we can then screw into. To fix the jig to the tool, we simply place it on here, open the drawers very lightly so it sits in there snugly, then use an M3 by 16mm screw. It doesn't matter if it's a cap head or button head or whatever, it'll just fit in there, and then you can use your Allen key or appropriate tool to screw that down into place. So you can see how that's just rigidly mounted there, that's not going to move or wiggle or wobble or anything. And then the jig just simply slides on to the dovetail. And it's designed so that it doesn't fall off. If yours do fall off, then you've probably got a slight problem with the tolerancing of your 3D printer. I've got a small calibration guide on my website that you can follow that should help you resolve that problem. So how do you use it? Well, it's really rather simple. You keep the drawers open, you push the wire in until it touches the jig, you crimp down as normal, and it cuts an amount off the end. This particular one is around 1.5mm. But you'll find if we cut that end off and do exactly the same again, and we measure it exactly the same again, we'll find that it's again exactly 1.5mm. If you need a different length, you can just take off this piece, bring in your other parts which you've printed, and put that on instead. And that will then give you a different length depending on what you need. These are all not printed quite right, so these ones don't fit as well, but you get the gist. These were prototypes, but the gist is they all come in different size tips. The tips are different lengths, so the jig length that they cut is very slightly different. When the ones that you find on my website will actually be marked with the length on here as well, although that may change slightly depending on your tool and how it's assembled. So 2mm might end up looking like 1.5, for example, but it will be the same every single time. To build one yourself, the first thing you want to know is probably where you can get the STLs. So very easy, link in the description to my website, that's where you can get them from. In terms of material, pretty much anything will probably be fine. Probably avoid TPU because it's a bit wobbly, but ABS, PLA, PETG, all those sorts of things, absolutely fine. PLA is obviously the easiest to print. In terms of the tools you need in order to build one of these yourself, obviously something to remove the original screw and add the new one, depending on what heads on that you have. You'll obviously need a 3D printer to print the parts, or you can probably get somebody else to print them for you. And that's pretty much it. Very limited in terms of the tools needed. Printing the parts is also really very simple. For the actual jigs themselves, you can print those on their side. You shouldn't need any support material. And for this piece, you print it with this face pointing downwards. There'll be a little ring that points up at the top, which is what fits into the part, as I showed you in the assembly. For the main part and one jig, it takes around half an hour on a Prusa Mark III on the kind of standard profile. If you want to print faster, you can. Obviously, like aesthetic quality, generally not that important here. As long as it fits and works and holds on without falling off, then you're pretty much good to go. Up to now, I've just showed you this dovetail version, which is probably the simplest version. It's definitely the easiest to make and build into your tool, but I've also made a magnetic version. I had made a magnetic version, but I've lost the pieces. This magnetic version is very, very similar in terms of its overall kind of size and geometry, but instead of using a dovetail to mount the jig to the tool, it uses a magnet. So this is a 6x3mm neodymium magnet. There's one on the tool part and there's one on the jig part. So if you're going to get a full set of jigs, which at the moment is 5, plus the one on the tool, that's 6 magnets in total. Obviously, I moved away from this design because 6 magnets can be fairly expensive, like depending on where you're getting them from, and they're not entirely needed, but it is definitely quicker to add and remove them. And if you're having trouble with the printing tolerances for the dovetail, the magnet sizing can be a little bit easier, and you can obviously glue it in if it's a little bit wibbly wobbly. So there's an alternative solution if you'd like a magnetic one rather than a dovetail type. If you're finding that you need a little bit of help with assembly, printing or parts or something for this modification jig, then you can find a link in the video description to the Vector 3D Discord, and there somebody else or myself will be able to help you with exactly whatever you're having a problem with. It's fairly simple, so hopefully you won't need that, but it's there if you do. Or you can just come along and chat about other 3D printing things. So that's it from me today. Hopefully you found this very useful. I've certainly found it really useful for stripping lots of wires to just the right length every single time. It does work honestly very, very well, and I hope you find lots of value in it. So thank you very much for watching. Again, check the video description if you want to get the STLs for this, and I'll see you in the next one.